So this video is going to be an extra credit opportunity, and you're going to be using Codeskulptor to calculate the model sizes and model orbits for the solar system. So if we were to imagine the solar system as a model, and we use an exercise ball for the sun, how big do you think the other planets would be, and how far away would their orbits be? And so why I like this activity is because it helps us understand that the pictures that we see aren't true representations of the solar system. Because sometimes you have the pictures based on the size. So this picture shows you the different planets and the sun relative size to each other. So you'll see that the sun is really big, and Jupiter, Saturn, Uranus, and Neptune are kind of big, and then the terrestrial planets are small. But what's wrong with this picture is it doesn't show the distance between the planets. So if we try to show that, then you'll see that the picture is much different. So the distance is now more accurate, but now you can't see the details of the terrestrial planets or the details of the Jovian planets. And so so getting a good model is difficult. Now there is a nice video that I'll show you in class that shows a person who did this model out in a desert, and it's really cool. So what we'll do then is we'll use Codeskulptor to figure out how to calculate the size of the different planets and how far away they would be. So there is a starting template one that I created for you. So if you open that, put your name and push the save button. Remember, save often so that you don't lose your projects and stuff like that. In fact, I'm going to, and I apologize I didn't do this for you, I'm going to make a new slide here that says saved projects. All right, so the first thing we do is we open the link, and we'll replace the line 1 with your name. And immediately, let's save it and copy and paste that into your slideshow so that we don't lose it. Now that we have your name in there, let's just look at lines 3 through 6. There's nothing going on here other than the program is going to print out 3 lines of code, and it talks about how if we imagine the sun to be the size of a exercise ball, what would the other objects be? So let's start with Mercury. So how did I do Mercury? Well, obviously we do a hashtag Mercury to separate the planets, and I put 2 calculations here. I put Mercury size 5,000. So what does that mean? Well, in the slideshow you'll see that Mercury's actual size is 5,000 kilometers. And so in our program we put 5,000. And Mercury's orbit, in the slideshow it says it's 58 million kilometers. And so in the program we put 58 billion. Now remember, don't put the commas because that messes up the program. So you have to make sure you count the number of zeros. Now that I taught the computer the real Mercury size and the real Mercury orbit, I'm also going to teach it the model size and the model orbit. And I already calculated this for you. So the model size of Mercury, believe it or not, is only 0.54 centimeters. That's the thickness of a mechanical pencil lead, right? A 0.5 mechanical pencil lead. So if the sun were the size of a exercise ball, the Mercury would be smaller than the tip of your mechanical pencil. So you wouldn't be able to see it with much detail at all. And that's just crazy. Remarkably, even though it's that small, it is going to be 62 meters away. So how far away is that? That's more than half of a football field. So if you put the exercise ball in the end zone, Mercury would be half the football field away. And remember, it's the size of the tip of a mechanical pencil. So let's see what the program does so far. So it tells us that Mercury's size is 0.54 centimeters. Mercury's orbit is 62 meters. And that's just the first planet. So now let's do Venus. So lines 18 through 25 I gave to is Venus. So it's the same thing. What we do is we put Venus size is 12,000 because that's what it says over here. And Venus's orbit is 108 million kilometers because that's what we got from here. So all you do is you take these numbers and you put them into the program. But here's where it gets a little trickier. We need to calculate Venus's model size. So we're going to use this ratio. So we're going to take the real Venus size divided by Mercury size and multiply that by Mercury's model size. And what that does, got to make sure you print our answer. And what that does is it tells us that Venus would be 1.2 centimeters or 1.3 centimeters, which is still pretty tiny, right? Maybe the thickness of your pinky, right? Same thing with Venus's orbit. Now we can use the calculation. Venus orbit divided by Mercury orbit times Mercury model orbit, and then that gives us Venus orbit. And let's print our answer. So it will be 115 meters away. That's longer than a football field. So let's continue with Earth. So line 27, Earth. So let's do it step by step again. First thing we got to do is we got to teach it the real size of the Earth. So from our slideshow, we'll see it's 13,000 kilometers. So we put 13,000 there. And then we need to do the ratio. So this is the trickiest part. When we did the Venus model size ratio, we taught it Venus model size is equal to the real Venus size divided by the real Mercury size times the fake Mercury size. So same thing with the model, same thing with Earth. For Earth's fake size, the model size, we're going to take Earth's real size divided by Mercury's real size times Mercury's fake size. And then we're going to print out a sentence that says Earth's size will only be, and then the Earth's model size is calculated in line 29, so we put it in line 30, comma, centimeters. So for the models, we're only going to use centimeters. And voila, 1.4 centimeters. So let's put that into our slideshow. 1.4 centimeters, which is slightly larger than Venus, which makes sense, right? 13,000 to 12,000 kilometers is slightly bigger, 1.4 centimeters to 1.3 centimeters. So how far away do you think it would be? Well, here's the orbit, 149,000 kilometers. So we'll take Earth's orbit, and we'll put 149 million kilometers. And then here's the tricky part again. We have to calculate the model orbit. So we'll take the real orbit of Earth divided by the real orbit of Mercury times the fake orbit of Mercury. And we'll print out our answer as a sentence. Earth's orbit will be blank meters, and then that blank will be replaced with this variable, and then we'll keep a print. And it will be 159 meters away. So that's almost 2 football fields already. So you got to imagine that. The sun is the size of an exercise ball in the end zone, and you have to walk 2 football fields before you get to Earth. And once you get to Earth, it will be the size of your pinky. All right. So let's take the 159 meters and put it into our slideshow. 159 meters, and it's 159.3 meters. All right, so as you can see, we did Earth. Now it challenges you to continue with Mars, Jupiter, Saturn, Uranus, and Neptune, using these actual sizes to find the model size, and using these actual orbits to find the model orbit. And I put the sections here, and don't forget to save often. Good luck, you guys.